In this IoT Radar, I'm meeting up with Jens Hagemeyer, and he's from the Bielefeld University in Germany, and we are going to discuss IoT, but not just IoT, we're going to discuss very efficient deep learning IoT. Good morning, Jens, good to see you.
Good morning.
Good morning. Very efficient deep learning IoT. Deep learning and IoT. What exactly are we talking about?
So, actually, very efficient deep learning in IoT, or that's basically the European funded project that we are working on. We call it VEDLIoT. So that's how we pronounce it. It's about combining IoT with deep learning. So traditionally, machine learning, AI or deep learning is something that was going to happen in the data center, in the cloud, so to say, and let's say not so much at the IoT or edge level, so to say. And the goal of VEDLIoT is actually to combine these two things. We are focusing on deep learning, which does not mean that we are not looking into the other topics of machine learning, but deep learning is for sure the focus there. So that's actually the combination of deep learning technology with IoT, which then states specific challenges, so to say. So how you're going to do this, because the reason that this was done traditionally in the cloud is basically because there's huge computing power required for this. You need to do all the calculations, all the inference or learning, so to say, where you let's say normally need a powerful workstation at least, or a complete data center in the best case, so to say. So a real powerful GPU, for example, things like that. The goal of VEDLIoT is to combine these two things and to really enable having the deep learning happening at the IoT at the edge level, where you have the data, so to say.
Can you say that, because indeed you're telling, the deep learning is basically moving away from the data center and of course the cloud solutions to the actual IoT device. Is there a trend in processor architecture or in memory? Because there are lots of technical issues to deal with. Sometimes you have to deal with battery, power consumption. You have to deal with the actual processor architecture. Are there now on the market solutions that will help you in this whole process of very efficient deep learning?
Within VEDLIoT, we are actually developing our own hardware platform for this thing. So VEDLIoT has a specific hardware focus. So on the one hand, we are developing our own hardware platform for support of various the whole range of things, so to say. So from the, let's say, quite simple device happening at the far edge, where you just have, for example, a camera connected to some processing, over to the near edge, and even to the cloud. That's a modular platform that we are looking at there, so that will enable to put what we call microservers. Microservers are you need to think of a modular architecture, and microservers are the processing nodes, and we are basically having those different microservers, which is actually embedded technology. It's a computer on module in technical terms, and we are putting this then on the different platforms depending on where that's needed. That gives us a quite flexible platform, so to say. We also
Sorry.
Yes, sorry. we are also having an accelerator focus. That is the second part of your question, in order to improve energy efficiency. Because if you need, let's say, to do all the processing at the edge with, for example, limited energy budgets, with maybe also space requirements in terms of heat dissipation and so on, you need to have accelerators, so hardware accelerators, in order to do this efficiently. Otherwise, you will be it will not be possible. That was the reason why those things are initially done at the data center.
Now you're touching on something interesting, I feel, because basically, if I look around, there are many hardware solutions currently also looking in IoT devices, also in machine learning. But you are saying we are basically developing our own hardware platform. Doesn't sound that a bit like reinventing the wheel? What is actually the benefit of developing your own hardware for this specific research?
So we are let's say we are not starting from scratch. Obviously, we are integrating let's say what is available on the market. So you need to think of it like we did a quite extensive benchmarking campaign, benchmarking things like, for example, the different NVIDIA jets which are out there, all the way from Jetson AGX to NX to Orin to all kinds of things in the GPU space. We benchmarked also quite a number of specialized ASICs which are there on the market, and we are actually working together with different ASIC vendors. What we do in that platform is, so it's not an ASIC project, it's not a chip project. We are integrating things on the market to have a then flexible platform with supporting industry standard form factors like SMARC, like COM-HPC, like COM-Express. We are part of the different PICMIC work groups there, where we are also driving those computer or module standards like COM-HPC, like COM-Express, also SMARC, for example. So that it's basically not reinventing the wheel, I would say. It's combining things so that we can, on the one hand, be flexible, be close to the standard, and still being able to flexibly combine those. Because what is currently a little bit missing in this huge space of things which are there is really the capability of heterogeneous processing. So when you are, for example, looking to do GPU, for sure NVIDIA offers you everything that you need. Mm-hmm. But if you want to combine then this GPU, for example, with an FPGA or with a specialized ASIC, you need to come up with your own solution again. Okay. And when you want to switch from GPU to FPGA, it's the same story. Okay. So our platform basically aims at combining these things in a coherent modular architecture, so that you can really exchange things, that you can combine things, and that you then can choose what is best for your application, for your process.
I see. Is it also with the purpose to make this hardware available for other parties? Will other research institutes or companies which says, okay, I'd like to have a better understanding of what this hardware is, will this become available? Is it will there be a sort of a hardware solution actually, or that people can have access to?
I mean, in the end of the project, we hope to have this commercially available for sure. So that's one exploitation from the different project partners. A part of this platform, because it's not totally or entirely new development, so parts of the platform are existing already, and they are available as we call this Rex box or Rex platform for resource efficient computing. Basically, it's from our partner Christman, and we have developed this together with them for quite some time now. Mm-hmm. Also within partly as a product development, partly in let's say joint research projects.
Yeah. Now you're doing all this research into the hardware. Probably also you're looking into software solutions as well. What I'm always interested. What exactly are your new insights? What did you find out, which you say, okay, this was really interesting, or this was really surprising, going through all this research? What was that?
I mean, it's a big project, so to say. So we are 12 partners all across Europe, so to say. So there's let's say lot of parallel activities. Okay. VEDLIoT is currently at halftime, so it's a 3 years project, and we just, let's say, last week finished our midterm review successfully.
Congratulations.
And yeah, it's so lots of things are still ongoing. We have first results. That's why we also let's say quite recently visited a lot of events and conferences. So what has done or what has been done so far? So if I'm trying to summarize, we did as said quite extensive benchmarking. Of the different platforms available and so on, and we are also still working on our own accelerators based on FPGAs. This is a very, let's say, dynamic field. So as you know, lots of established big companies, the big players. Then also we are especially trying to also talk to startups there from the US, from, for example, France, and actually having quite interesting collaboration possibilities on the one hand in just integrating their technology, on the other hand in bringing our applications into their focus, so to say. So that is something which is let's say interesting. Also from a research perspective, without going too much into details there, because we have NDAs and things, but also from a let's say business or collaboration perspective.
So basically the whole project is in full swing, I understand, with lots of different partners. I'm just wondering, what exactly are you looking at? What sort of applications are we talking about in this VEDLIoT, very efficient deep learning for IoT? What is there? What are you looking at that is not yet available on the market? What are the applications?
So I mean, we have a wide range of applications. So within the project, we have core applications, so to say, from areas like smart home, industrial IoT, and also automotive. With our partner VEONIR, for example, that's a Swedish company. We are looking at a pedestrian detection system integrated into the car, which is then really aiming at doing the whole process distributed, so to say. So let's say traditionally you would just have everything, so the pedestrian detection and collision avoidance system, so it's an automatic emergency braking system. Basically, you have all this integrated in the car in one single unit, which is okay, so to say. But I mean, as the car is operating into quite different environments, into a city's environment or at the countryside, we are looking at extending this and doing the processing distributed. So doing a part in the car, doing a part in the edge. So for example, in the base station, and even let's say some parts in the cloud, which will then for sure be more efficient on the one hand and enabling lots of different opportunities, because the system is basically adapting to its environment. But on the other hand, there are also lots of challenges when you think of functional safety, especially for automotive, all the requirements engineering, which is associated to this. So this is something which also VEDLIoT has a specific focus on. We are developing our own requirement methodology for what is called IoT systems. IoT systems which are using AI or which are using deep learning, and this is actually something which is already quite, let's say, finished. I mean, we are still working on it, but we have already results on this, because this was something which we had a particular focus on in the first half of the project. And that is, I guess, quite interesting also for let's say parties outside of the project, because it let's say addresses those typical problems that you have when you apply machine learning problems to the IoT domain, especially to let's say applications that require functional safety, that require robustness and so on, because people are always asking, is this let's say verifiable, certifiable, is this explainable, all those different aspects, which are also then going into the direction of federated learning, for example. And yeah, so really, let's say, for this application, the central challenges are really doing this distributed processing and having those security and safety aspects integrated are the key challenges. Then we have other applications, as I said, for example, from the industrial IoT domain, we are doing this together with Siemens. There we are, for example, looking at a predictive maintenance application for motors, basically. So the idea is that you have a small device that you fit to your motor, and then using deep learning methods, you are able to then cover a wide variety of motors and predict their failures. So that is for sure lots of sensors and lots of processing. So basically, a deep learning based sensor fusion also. But you want to because it's a retrofit device. You want to have this battery operated, and you want to have this battery running for like at least 2 years. So energy efficiency is key there. And also, let's say, having this really validated for that huge set of motors that you can think of. I mean, that is also a challenge. So to not, let's say, overfit this for one motor, because they have something like this developed traditionally for one specific motor with one specific model. And it should now be generalized. So
I see. Yeah.
And
sorry.
Maybe just to mention, we have also, let's say, more. We have something which is then focused on DC switching cabinets, so detecting electrical arcs. Okay. There you need to be fast, because you want to, if there's really an arc, you want to be you want to be fast in basically preventing or switching things off. But you need to also be accurate, because if you are detecting an arc and there is no arc, you are switching off your whole production line for nothing. That is a killer. But
so you have to double check.
But if there is an arc and you don't detect it, that's also a problem. So accuracy is key there. So you need to have very, very low false positive and false negative rates, basically, in order for this application to be viable. And then we have different applications also from the area of smart home. We have a smart mirror, and we have also what is called an open core in the project, which has just closed. So we have our applications selected, and the idea there is that we have additional applications then in the project, and we have, for example, something from agriculture in there, something from medical, something from industrial IoT again. So we are opening up this complete project right now in the middle of the project, so to say, where we have our first stuff developed, to also third parties, which we are also supporting in terms of funding, so to say, so that we get additional feedback, what we need to improve, and we widen our use cases, so to say.
Well, as I already mentioned, I think you're looking at a very busy next 1.5 years to the end of the project. I hope we will be able to catch up, perhaps in 1.5 year time, and to hear more about how the project and the whole research ended. Good luck with your research, and thank you very much for explaining all this for the IoT Radar.